This is the sky. So, okay. This is the sky, and this is the land. And where the sky is, this is the earth. And now, how do we know that the earth is? Well, today's science is about that. Hey guys, it's me, Mortimer Snerd, and today I am not. And you probably know me from the Late Show with Mortimer Snerd, but I'm no longer doing that anymore. So now I am now Mortimer the Science Guy. So first we'll start the opening credits, and then we'll show you the film. Pretty neat Earth, huh? Yeah. Mortimer the Science Guy, brought to you by the sun. It's cool. It's awesome. But in space, if you try to land on it, you will get killed. You and I live on the Earth's crust, a thin layer of solid rock that's able to sustain life. And now what's underneath the Earth's crust is different. It's melted rock. It's molten rock. And how do we know that? Because there are volcanoes. Yeah. Volcanoes are the only way that we tell that the Earth's crust is different from the outside of the Earth. That what's inside of the Earth is different from the outside. Now, even though the Earth's crust is very thin, according to Bill Nye, we've never been able to drill all the way through to the molten rock in the Earth's lava, because that's why, according to scientists like you, volcanoes are so important. They give us sort of a window into what's underneath the Earth's crust. Isn't that wild? And so I'm standing outside now of what the Earth's crust is now, I don't know about you, but the Earth's crust is really different from the other side, because right now you and I are standing on the Earth's crust, and it seems pretty hard, isn't it? But now scientists have known that the Earth is made of plates, not cheap plastic picnic plates, but tectonic plates, and tectonic is the Latin word for build. So the Earth's crust is built of tectonic plates, plate tectonics. So and people caught on to the idea that the Earth's plates were all together when they realized how much South America seems to fit in next to Africa. Not that bad. So, I mean, now they believed that one time the plates of the Earth were together, called Pangea. And Pangea, well, that means whole Earth. See, not that bad. And that's why and at one point they spread it apart. Now, where the tectonic plates spread it apart, that's where we get volcanoes. And where the plates are coming together, that's where we get mountains. Yoli, 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 yoli. So that's proof that now the Earth's tectonic plates are still moving the plates are still moving even today. In fact, North America is moving away from Europe about this much every year, about 2 centimeters. So 2 centimeters every year. Well, thanks for joining me on Consider the Following for that. So, yeah. So you have to consider the following in that. Now, I can't go to Mount St. Helens, but I can tell you that that Mount St. Helens has a crater now from 1980. I mean, in 1980, it blew up. Just blew up. It's not one of those oozing hot rock lava volcanoes. No, pressure just builds up, and then Mount St. Helens was erupting when some of the first pioneers were coming out to this area. Mount St. Helens was erupting. It erupted off and on from the year 1800 to 1857. So it can erupt again, and it will. See, Mount St. Helens is a young volcano. It's a very active volcano. It's building itself up and destroying itself. It's gonna erupt again. We just don't know when. Now listen, there's 2 kinds of volcanoes. You know, I'll just use grass for example. Some that ooze molten rock, and others explode. Sorry. Yeah, I'm not kidding. Some volcanoes ooze, and others explode. Oh, sorry. Yeah, so here I have my goggles of science. You know, let's come on, this grass off, you guys. There we go. Now listen. Now, I'm not kidding. See, not only are there volcanoes, but there are geysers. Geysers are hot water. There's hot water underneath the Earth's crust, so it's hot. Now, you can make your own geyser at home, but not in the ground. It involves very hot water. So you should have an adult around. Cash, can you come over here for a minute? Because you're the adult. Sure, okay. Yeah, so we should have an adult around. So here's what you need. A heat-resistant glass funnel. If it's glass, it has to be heat-resistant. Hence the term, heat-resistant glass. Yup. Next you'll need a pot to boil the water in. Yeah, because this kind of geyser looks the coolest in a glass pot. Yeah, so set the funnel in the pot and get the water boiling. And get some tin foil and poke a hole through it that the tube will make, and put it down over the tube, and the tin foil acts like the Earth's crust. Yeah, and in a few moments you'll have a geyser. The water builds in the bottom of the pot, making water vapor. Yup. The vapor expands and forces water out of the tube. Yup. But don't expect this. But when the water comes out of the tube, the water doesn't come out all at once like a hose. It doesn't. Instead, it pulses. It only squirts once in a while. The same thing is true in the Earth, like Old Faithful. The pressure builds up and forces water out of the ground. Not that bad. Yeah, I'm not kidding. Science is amazing. Truth, isn't it? Now, there are caves around here too. Oh yeah, like we can't go to a cave in a mountain in Montana, but caves have a lot of stuff. But caves have interesting rocks, stalactite, stalagmite. tight night. Yeah. Stalactite is on the top, and night is on the bottom. Tight night. Yep. Now, listen, now, like, we know that the Earth is round, but do you want to know how we know that the Earth has a core? Oh, well, like, if we had an earthquake, like say this is the, like, say, my hand is the Earth, okay? See, when an earthquake happens, like, right here, people feel it on the other. Like, they thought if the Earth was liquid all the way through, then if an earthquake happened somewhere over here, people would feel it all the way over here. But let's say we can cut the Earth in half, all right? And what will we get? Yeah, a circle. So this, like, something like a rock or something. Like this rock right here. This is kind of like the core, but different. It's not round. Now, if we put it like here, like a flashlight was over, like, say the sunlight is like an earthquake happening. As you can see, if I look in the middle, I can't see the sun. But if I come over here, I can. And then over here, I can still see it. And then when it comes over here, I can't see it in the middle, but I can see it over here and over here. Yeah. See, some people think that if the Earth was liquid all the way through, people would feel earthquakes from here, here, and here. But that's not what happened. You see, there has to be something blocking it if the Earth wasn't, if people don't feel it on the other side. Yeah. So that's how we knew we had an earthquake. Well, thank you for joining us on this segment. We'll show you how to make a geyser soon. Yeah. Let's say this English muffin is like the Earth. It's round like the Earth. And just like the Earth, it's got a thin, hard crust. But unlike the Earth, we can easily cut through it here in the lab. All we need is this table and this bread knife. See, it's got a thin crust, just like the Earth. Now, I mean, the Earth's crust may be thin, but it's so thick enough to sustain life. And so all animals and plants, including you and me, we all live on top of the Earth's crust. So that's good. That is good. Now, how do we know that what's on top of the Earth's crust is different from the inside of the Earth? Well, have you ever heard of volcanoes? So now, I'm gonna show you a picture of. So I'm gonna show you the big. I'll show you by pictures once I edit this video. The big ball Earth of science. See, it's surrounded by a thin crust. Now, everything is on top of the crust. Even the oceans are slashing around on top of the crust. Isn't that wild? Let's take a look at what's inside. There you go. There's the inside of the Earth. You got your core that you just saw. It's solid iron. And then there's an outer core that's iron and other metals. And then that other part's called the mantle. It's gooey like hot tar. And then that black line right there, that's the crust. It's nice and cool to sustain life. Alright, you know what, Hand? If you want the English ornament so much, take it. Take it. Anyway. The core, it's around 1500 degrees Celsius. The mantle, that's around 1200 degrees Celsius. I mean, that's way over 2000 degrees. And then the crust, it's cool and hard as a rock. Now, I said this earlier, but if the I didn't say this earlier, but if the Earth was like an egg, the Earth's crust would be about as thick as an egg shell, and the white would be like the mantle, and the yolk would be the core. But of course, you could eat the egg. That's true. And I'm a science guy, so I should know. Now, say if you were a hitchhiker. Now, let's say if you were a hitchhiker. Yeah. Thank you, Hand. Can I please get through my sentence? Okay. Yeah, that stupid Hand that was supposed to be introduced in the show. Moving on away from the Late Show. Anyway, so let's say if you were a hitchhiker, like Yukon Cornelius here, then you would be like volcanologing anywhere, and like you could volcanology, like, you know, you got your handy bag. Now, I just noticed now with this Yukon Cornelius plush, somebody put this in here, which is supposedly to be part of his mustache, but I think they just tore it. Whoever owned this must have torn it off because as you seen the movie, they just wanted his mustache to look exactly the same. So just put that back in there. And thank you, Yukon Cornelius. Now, Yukon Cornelius here is a pal of mine. He is still a hitchhiker. And yeah, he's still good. So we'll just set him right there for now. Now, I know that you guys have been wondering why I ended the Late Show. It's because nobody would. Well, it's because I know we canceled it after one episode, but we only canceled it after one episode because nobody was watching. Well, some people were, but some people weren't giving us some suggestions. And I'm telling you, I was sending I had the option for you guys to send us fan mail. Okay? So, please, just take the time and comment if you like this one, because nobody was listening to us in the other one. So everybody was probably doing this instead of watching our show. Cash, why are you on the floor? Because I'm just exploring what's on the floor. Get out of here, okay? Now I already know what you guys were probably doing. Is this? Oh. You guys were probably on your phones listening to your headphones, listening to music with your headphones. Now listen, I'm making an outdoor science show, and if you guys want to do this, then by all means, just do it. I mean, it's not hard to do. You're outside. Just do it, for God's sakes. Okay? Do it. Do it. I want you to see you do it. Well, thank you for joining me on... Take a look at this. Boiling water is hot. We have some boiling water here on our oven of science. Don't mind that Toy Story. Harry's just watching Toy Story. Now listen, when I say hot, I mean hot. This is paper towel. Hot. Hot. Big metal soup pour. Hot. A towel roll. No, that is one hot paper. Now the way, when it's underneath the Earth's crust, it's hotter and it's easier, and so it's neat. See? It's hot. So now we cooled it down and it won't be hot anymore. Hey Cash, can you walk with me to throw this away? Sure. So thanks Cash. Sure, I'm gonna go away now. Okay, now listen. What I just did here today, don't try this at home. Okay? It may look cool, but it's actually dangerous. So don't do it at home. Okay? Good. Now, the reason we have this is because we're making macaroni and cheese of science. I'll teach you how to make it when the water starts to boil. Well, that's our show. Kinda hot. I mean, cool. You know what I mean. You guys walk back to our house safely. I've got some serious hiking volcanology to do. See you around the cross.